So I got a fun session for you guys today. Well, hopefully it's fun. Um, so obviously it's a coding class, right? So I'm gonna spend a little bit of time in the first hour to help you guys set up the infrastructure of where to code. Obviously, the location is gonna be on VS Code. That's my preferred location. It's not a requirement for you guys. If you guys want to use other platforms. Some students use Anaconda. Some students just develop code on their own locally. Some students use Colab. Either way, it's no problem at all. I personally don't have a preference. I just want to be. I want to make it as easy as I can for you guys, so you guys don't have to spend time or waste time to download 50 Python packages and figure out the different container, different versions, things like that. So hopefully when the project starts, you guys just focus on the project itself and then figure out the code of the project and just take it from there. You don't have to waste time to set things up. So I want to kick things off using the first hour to talk a little bit about that. That's what I want to achieve by the end of the hour. And then we'll dive into the lecture content, which is linear regression. So we're going to start from there. And then linear regression is pretty much going to be setting things up for a classical machine learning technique. Like if you know linear regression, like very solidly, yeah, come on in. If you know linear regression like pretty well, like 100% you know pretty well, then it should be a very good estimate of the rest of the algorithms in the class that we're going to introduce. So I will consider linear regression like the golden egg, right? Like you absolutely want to nail that down. Yeah, come on in. Yeah. You absolutely want to nail that down, right? If you miss out on linear regression, obviously the other algorithm, you're gonna have a problem. And then linear regression is also gonna be like literally the first step of neural networks. Like the absolute first step of neural networks is gonna be linear regression. And if you miss out on linear regression, then pretty much the rest of neural networks you're not gonna understand. So that's the plan for next hour. And then I want to spend the remaining time talk about project one, because the first deadline is coming up, I think February, like I believe it's first week February. So I want to set things up for that. And then I don't think the first submission is hard. I think if you just listen to every single thing in the lecture, you have a good handle of a first submission. I designed a project like that on purpose, just because I want to make sure that everyone's following. So the first submission is meant to be easy. It's not meant to be hard. But of course, if you want to, go out of your way and design something new, please feel free to do so, right? Yeah, so that's it for the plan for today. Any questions? Good. Okay. All right. Okay. So number one thing in this class, right? You have to know how to make API call. If you don't know how to make an API call, you're gonna miss out on OpenAI, you're gonna miss out on ChatGPT, you're gonna pretty much miss out on 90% of the class. So number one thing, you have to know how to make API call. So what that means is you need to have account with OpenAI. And then unfortunately, what it also means is you might need to enter credit card number. The money does not go into my pocket. The money also hopefully does not go into OpenAI's pocket if you know how to budget. And hopefully you don't blow up your own budget. Like I've been using a bunch of different models, and this is kind of like my personal record. I'm on ChatGPT probably like 8 hours a day. And then you can see from January 1st to January 29th, I'm paying about 10 cents to 20 cents, probably less than that every single, like 90% of these bars, I'm paying less than 10 cents. And I'm on ChatGPT like 8 hours a day. So hopefully this give you a taste of how much you guys should be spending. Like I have students come to me like they one day have a bar that blows up to like $10, $20, $50, something like that. That does happen occasionally. What that basically means is there's a leak of your API key. So we're gonna talk about that when you commit code to VS Code or commit code to GitHub. Obviously, it's up, it's your own key, or you don't want to leave on the table or throw out there in the open website, in the open internet, right? That's kind of up to you. So the only thing I can do is give you guys a reminder. of what's a safe practice of Python code and how do you commit so that when you have similar problems, you don't blow up your quota. Does that make sense? But basically, everyone needs to have OpenAI account. What that means is come to platform.openai.com, and then all you gotta do is log in. I just use my Gmail, so because that's the easiest one. And then it's been a while since I look at the initial page. I think a while ago someone told me they give you like a $20 monthly free credit if it's the first time you're signing up. I don't know if that's the case right now because I had the account for like a couple of years now, and I don't know if they still do that. But I think based on the way I saw it is you do need to enter a credit card number just for the account to be live, right? And then all you gotta do is go to API key, and then you'll be able to create your own API key here. Literally just click on that button, and then they give you a key, and then you just gotta save it. Any questions? What's that? Can you what? Yes, of course. You can use anything you want. Yeah. OpenAI is one example. There's Mistral, there's Anthropic, things like that. You can feel free to use whatever you like. Yeah. Yeah, since you mentioned, I think later today I'm gonna probably show you guys Anthropic. Because OpenAI unfortunately doesn't do VQA, vision question answer, meaning that you can only talk to it. You cannot send an image and then ask a question. For whatever reason, they don't do that here. They certainly have the skills to do that, but somehow they don't do that. It's kind of like interesting question. Anthropic fortunately does that. So if you get an API key from Anthropic, you can actually send an image to Anthropic API and then make an API call and ask questions. You can do all of that. So Anthropic, yes. And of course, same thing, Mistral AI, Llama or Llama, whatever you want. This is just an example. So once you have an API key, obviously you want to save it, right? The easiest way that I found is to save it in Colab. So this is my Colab. Let me zoom in a little bit. If you go into Colab, let me just show you. Let's say I go to my Google Drive, and then you click on this new button, and then you click on more, and then the Colab should be here. If you don't see Colab there, you can just click on this connect to more apps button, and then you can type in Colab. The first thing should be it. You just gotta install it. So since I already installed it, so I'm not gonna do it again. But if this is the first time you're looking at, that's how you acquire the access of Colab. So what is Colab? Colab is essentially a Jupyter notebook that lives in your Google Drive. So you don't have to worry about virtual environment. Yeah, come on in. You don't have to worry about virtual environments, Python packages, whichever version of Python packages, how you use it, things like that. And then another benefit of using Colab is if things go wrong, right? Let's say you type something here that's like wrong, or you install some package that breaks the system or something like that. All you gotta do is go to runtime. You can change your runtime type, or you can disconnect and then delete that runtime. And then once you reinitiate, it gives you a clean slate, right? It gives you complete everything clean. You don't have to worry about anything anymore. So that's kind of like the benefit of that. If you're doing this locally in your computer, then crap, you're gonna have to uninstall everything, reinstall everything. Then that's kind of like your own valuable time you have to go through. So just heads up on that. So once you have Colab, you have notebook, you have Python code here. We talk about API key, right? So you press that button, give you API key, you copy it. What are you gonna do, right? The safer practice is you go to this button here. This is called secrets. So it's Google's own way, excuse me, it's Colab's own way of managing secrets. Some of you developing code locally, it's called .inf. So this is like Colab's version of .inf. It's very simple to create a secret. All you gotta do is scroll down, literally just add new secret. That's it. You can add new secret, just copy paste the API key there, and it will basically just save here only for you because it requires logging. So no one else can see what's going on here unless you show them your API key. So that's pretty much about that. Now let me show you how to use it. First things first, obviously you want to install it, right? OpenAI is kind of like a competitor of Google. So unfortunately, they don't pre-install it for you. The way to see that is, I don't know if the regular Colab has it, but for Colab Pro and Pro Plus, you can come down here to open a terminal window, and then you can type out the pip list. It will show you a list of packages that's pre-installed. And then you can just like scroll up to O to see if OpenAI is installed or not. So OPQ, RST, wait, where's O? OPQ, RST, O should be somewhere here, right? Yeah, so I already installed it. That's why I see this package here. If it's the first time you opening a Colab or it's a clean slate of a Colab, like a new session, then obviously this is not going to be there. So if you run a pip list, it's a quick way of checking if you have the package that you need, right? So if you don't, then pip installer. One thing to mention is if you're going to pip install something, the default setup, it's going to be coming from this website called pypi.org. And then this is going to be the code that you can copy to install any packages, or you can just remember pip install. A small caveat is for OpenAI, you kind of need to keep an eye on this number because OpenAI constantly update their package and then they deprecate code once in a while. I like their students that I taught literally a year ago, and then I'm teaching them some code in class, and then a year later they deprecate that code, and then their entire software crashed because of that. And the reason that's the case is because they lost track of this version number. So I just want to give you guys a heads up. This, when I say version number, I'm talking about this digit here, 1.60.2. Yeah. So that's package version. We're going to talk about when you get into productionizable code. This version number is gonna be very important. So once you install it, obviously have your API key here. The way I do it is to use the Google's version, which is the syntax here, user data. And then if you don't remember the syntax, you can always go down to the left-hand side and you can find it down here. So they provide that for you. So once you load an API key, this is how you create a client. As a client means that you are designing a variable, literally just called client. And then the client is assigned to OpenAI class object. And this class object, you insert your API key in there as a variable. So that's what we mean by a client. And once you have this client, you can of course do your own thing, right? You can make an API call, invoke it, and then you can basically talk to it. So let's talk a little bit about this message component. Model is kind of easy. Whatever model you want to pick, obviously be aware of the prices. How do you know about the prices? Well, you got to come down here and look at your usage. I typically use 3.5 for like for example, this purple one. This one here, the purple one is GPT 3.5 Turbo 0125. That's what that means. Yellow one, obviously, you can look at the yellow one. So that's what I will caution you when you're making this API call. I think I forgot which one, but I think there's a 4.0 turbo version that's kind of like charging an insanely high price. Just be aware of that. I think they charge like $1 or something. And then if you're making 20 API calls, 20 bucks down the water. So just be a little bit careful with that. So that's the model. The next thing I want to talk about is this. So how it works is one API call, you're actually going to give a list of dictionary. So the bracket is called list. As a bracket is called list. That's a data type. And then the curly bracket is called JSON file or dictionary. So this is the dictionary, DICT. The messages, the body of the messages is always an array of dictionary or a list of dictionary. It always is that. And then this list carries the conversation history that you want this API call to know at that particular session. If you rerun this code with a new set of conversation history, it's not going to remember what you previously entered, right? So that's how we handle long-term memory. Just so you'll understand a little bit about that structure, this is not gonna be obvious right now. It's gonna come in handy when you're creating a flow of conversation, and then somewhere down the road you're like, oh wait a sec, I think I mentioned this before. How come it doesn't know? Well, it usually have something to do with how long this list is. It needs to be long enough to contain the memory, but it shouldn't be too long that it blows up a token size, right? So there's a sweet spot in the middle, and then it's kind of like up to your own design of the chatbot to be aware of what that sweet spot is, right? So if you're designing something that you allow user to enter article, I will probably design a workaround to make sure that this client can be called on the spot, because user is now dumping an article into your API call. But if user is not dumping an article, if user just talk to it, then by all means, you can just infinitely append this array. And then like a 100,000 token, this can go very long. So it depends on the use case. This message body is gonna change based on what you're doing. Same goes with linear. Like if you're gonna throw linear regression results in here, that's gonna play a huge difference, because you now got model, you now got data, and then whatever output comes out, you're then gonna rewrite it in the markdown file. It's gonna kill the token size. So be aware of how to design this as we get to that part of the class. So once you have this, you can just invoke it. Like for example, you can ask a question. Here I can say, what is 1 + 1? And then you can grab their response. It's just going to say 1 + 1 = 2. You can also say, tell me a joke, something like that. And then it's gonna say something that it's a joke. Whether you find it funny, that's up to you. but it is a joke nonetheless. So that's how you make an API call. And then there are other things you can do around it. You can build this into a class object that takes a conversation as a whole, and then you can build system around it, build your own chatbot, things like that. So let me take a pause. Any questions about this? Good. Okay. So that's the most basic thing. We're going to come back to that. There's going to be a system you guys are going to be using that relate to that. The next thing that's related to project number 1 is Google search. So you have to know how to make a Google search using Python, right? Not like I'm not talking about this. Today's weather. This doesn't count. This doesn't count as Python. So I'm not talking about this. I'm talking about how do you do this using Python programmatically, right? So what that means is you're gonna go to OpenAI, sorry, not OpenAI, SERP API. So SERP API is a website that builds the Google API into their package. Same thing, right? And the good thing about this website is that it's actually free. It actually gives you, I believe, 50 searches per month, completely free. So you can just keep using it. This is my own record. I'll show you what I look in a Colab environment in just a sec. But same story, right? You need account, you need to register, you need to go to API, go to the your account, find your API key, save it. I don't want to click on this because once I click on this, they actually show you the API key. They don't hide it, so I'm not going to click on that. But if you click on this, the API key is in there. Same story. I can show you SERP API. That's another notebook that I opened. You need to install SERP API, and then you need to install Google search results. So those are 2 packages that you need to install to conduct your own Google search, right? And then once you install it, you can then grab your API key just like that using the same syntax. Use the data here, use same syntax, grab your SERP API key, and then I have a helper function here that's designed that invoke the API. It takes a couple of things as input argument. Number 1 is obviously query, right? What is it that you're trying to search? You type in Google search engine something, that's the prompt, right? So that's a query. So that's number 1. It's very simple. Location here is hard coded to Austin, Texas. In your own case, obviously, you want to bring this up to front as the input variable so that user can change it, right? The interesting thing about location is it depends on use case. If you are searching weather, obviously location matters, right? The weather in New York is not going to be the same as weather in Texas, right? But if you are doing some regular search, like for example, news about stock market, location is probably going to matter less. Does that make sense? So this depends on your use case. If you say, hey, in project one, I'm not going to worry about location at all. I'm going to assume user don't search weather at all. That's totally fine. You just need to tell me that, right? And then you can basically just hide this somewhere in the function. You don't have to bring this up as input variable. Totally fine, fair argument. But if you're gonna design a code, design a solution or project one in a way that the location matters, then obviously this you need to bring that up to the front as input variable so that user can change that when they're using your code. The last one is obviously API key. Otherwise, this is going to give you an error. So once you invoke this API, let's say I'm gonna change this so we know that this is working. Let's say NVIDIA stock price, right? So like this is obviously news, right? Like it's this did not happen a year ago, right? This happened literally this week. So we know that this API is working. This API call is working. It is giving us news. Whether this is the link that you would see first time in the first link in Google Chrome search experience, that's besides the point, right? Because Google Chrome carries cache, and the cache is dependent on your previous search, the list of links that you guys see may or may not be the same as this link. Does that make sense? So I have students run this API and then they compare with Google search results and they freak out. They're like, wait a second, this is a complete two different lists. Well, it is true because Google engine is designed in a way that it gives you search engine by guessing what's probably good for you. Well, quotation mark good, not necessarily good. So that's what that's about. And then now I can probably take you to project one, just so we can connect the dot. So we go to, let's see. So if we go to project, go to project one. So now you can kind of connect the dot, right? When you are talking to a chatbot, the absolutely first thing you're going to do is this, right? There's going to be some sort of API call. But before you do that, what if you throw this into the SERP API and make an API call there and grab the results of the Google search engine, and then whatever that prompt, you throw that in here as a as an additional instruction, right? So that is going to bring your answer up to date. Does that make sense? So what I'm trying to say is, instead of just doing this, right? You ask a question here because I can replicate the same question. You're just not going to get anything. So if you type this query here, you're just not going to get any news because the memory of ChatGPT is limited to whatever data training data is collected, right? Which is not going to be yesterday. So if you just do this, you're not going to get the latest information. So the interesting thing here regarding to this project is when you're talking to a chatbot, user going to ask something. The first API you're going to call is actually SERP API. So you're going to throw user's query in here, make a SERP API call, grab this results, right? And then this results, you can then enter into this spot here as additional content. Literally, you can just say something like this. You can say engineered content, and then you can define that here. And then you can put user query here as the NVIDIA stock price. And then you can say, here's some additional info regarding user query, right? And then literally you can just put this in here. Like whatever this is, you can copy that here. And then if you know if you know if you know how to work around the string, you can even do something fancier. You can say result from news to be this, and then you can do a f string by putting the information here. Result from news. So now this prompt is enhanced with the results of Google search. So it's not just a generic prompt, 3 words, NVIDIA stock price, right? Obviously ChatGPT is not gonna know that. Now if you throw this whole thing in there, then this answer will be more meaningful. So I can run this, and now hopefully it's gonna say something, right? And whatever it says is gonna be based on not only what ChatGPT knows, but also based on the news result after the SERP API, right? So those are the basic building block I can give you guys for project 1. And the goal is straightforward. The goal is, okay, we have these links here. Great. How do we know which one's correct, right? So that's the question that we're going to answer in the first project. So in other words, in terms of logistics, I would say that the first project is asking for some sort of helper function so that it can actually read this link one by one and assign a score. Like for example, there's going to be a helper function that reads this whole thing and say, okay, the first link, I'm going to give 5 stars because Forbes, we trust that, something like that. And then the second link, maybe Market Watch, okay, fine, 5 stars. And then you go down link and then it's like, I think these are all fine. But if you go down a link, it's going to show you someone's blog or someone's tweets, right? That's probably going to be 4 stars, 3 star, based on how you design the algorithm. Does that make sense? So these 2 API are the most basic thing that you're going to need for project 1. So let me take a pause. Any questions? Yes. So which is kind of a different operations. Yeah, you can use whatever model you want. Yeah. How we, for example, how we are integrating to. Mhm. Yeah, you can use whatever large language model that you want. Yeah. This is just an example. The LLM, this API call, you can pretty much do whatever you want. I mean, you can download BERT from Hugging Face, and make your life easier if you want, right? So you don't have to go to API key, things like that. But if you're gonna download things from BERT, you do have to like you're gonna have to download the token, right? Download the token, download your parameters, and then that need to be saved somewhere. So if it's on Colab, every time you restart a session, you're gonna have to reload that. Yeah. So if you're comfortable doing that, then by all means, please do that. Yeah. Same goes with locally. You're gonna have to save weight somewhere, and then you're gonna have to manage that, right? Yeah. So you think that no. Yeah, you can use any of that. I know people use Anthropic, Mistral AI. I think there's somebody else using Together AI. Yeah, so you can use any of that. Yeah. Yeah, that's a good question. Any other question? Good. Okay, one last piece of puzzle I'm going to give you for project 1. It's how to scrape the internet, right? You have a link, right? You have a link. User asks something, you make an API call to Google Search. Google Search said, oh yeah, this is 5 links here that's helpful, right? You can't just look at this and assign a score, right? This doesn't mean anything. Forbes.com doesn't mean anything, right? You need to get in there, right? So how do you get in there? So that requires another package called Beautiful Soup. I have a code here, Beautiful Soup. So Beautiful Soup, I think, fortunately, it's not too big of a competitor for Google, so that they pre-install this for you guys in Colab. So you actually don't have to pip install Beautiful Soup. You can just say just directly load from BS4. So yeah, the code is here. All code will be online. You don't have to take notes or anything like that. I'll give it to you guys. You can use it directly on your own. And then basically the story here is I'll get this started. The story here is you have a bunch of links, right? You have a bunch of links, and then you want to get in there to see the content, right? So that's what we mean by scrape the internet. So the next helper function I'm going to give you guys is, let's say you take the first link, copy link address, and then you go here, and then you can literally just copy here. Just like that, Forbes.com, blah, 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 DeepSeek Panic, live updates. And then you can run it, and then it will give you a bunch of stuff, right? There's a lot of stuff here. Basically, it's like the article of this link. And then you can probably verify it by go to that link on a web Chrome, on a Google Chrome browser. But I think I have ad block here, so I can't see on my computer. But if you don't have that, obviously you can see it. So anyhow, the content is actually here. How it gets past the ad thing, I have no idea. So if you guys figure out how, let me know. But for some reason, this API call actually get past the ad blocker, which is actually very interesting. I need to look into Beautiful Soup to see how they did it, but it's actually very interesting. Anyhow, the content is now here, right? So let's go from take this journey again. So user journey, right? Enter something, NVIDIA stock price, and then you conduct Google search. Google give you a bunch of links, and then you want to assign a score, but you don't want to assign a score just based on a title. That doesn't mean anything. So you want to get in there. How do you get in there? You scrape it, right? You scrape it, and then the helper function is here. You can use a helper function. I think it depends on how the HTML is written. This parser might be different from website to website. I think HTML.parser probably covers majority of the website, at least based on a couple of experiments that I tried personally. I think it covers most of them. Sometimes if you get some weird website that's like, maybe it's not professionally done, maybe it's like someone wrote a blog somewhere, this HTML.parser might not cut it. It might just give you part of the website or like some weird string somewhere. It doesn't give you the whole thing, right? So when that happens, you just have to fact check this and then fact check the separator, things like that, to make sure that this code it's general enough to cover the website that you want to cover. But for majority of website, I would say probably 80-90% of the website out there, that's a common website, like the website that you know the name of, like Forbes Market Watch, if you're in healthcare, WebMD, like that sort of thing, right? Those websites usually this function should be able to scrape it. So once you scrape it, now here's the question, and here's exactly what project one is going to do, which is now you have this, right? This is the link. This is the content of the website. Okay, what is the score? How do we trust this? Is it 1 star or is it 5 star? So that is a question that project one is going to help you think about. Does that make sense? Any question? Good. Okay, awesome. Cool. Yeah, so that's pretty much it about the setup of project one. So hopefully these helper functions will give you a good basis of what project one is about. And the first draft, right? When I say first draft, I'm talking about first deliverable. So where's the deliverable? Just scroll down. Wait, did I miss it? I don't know. So first deliverable is going to be this thing. So first deliverable for project one, it's like I kept it as easy as I can. Imagine yourself a Python function such that it's going to consume a URL. For example, it's going to consume this URL, And then the Python function will literally just say, hey, the score is 90%. And then here's the explanation. So if you can somehow figure out a function such that the input is a string, a web URL, and the return of that function is going to be this JSON file, the JSON object, then you have a pretty good goal of the first deliverable of project one. And then we're gonna, as we move on to the class, we're gonna talk about what kind of algorithm you can use. I mean, the easiest thing is certainly you can use linear regression, right? But we're gonna talk about how you can convert string to numbers so you can actually do the linear regression, because linear regression doesn't work on strings, right? So we're gonna talk about that. Okay, so that's pretty much all the foundation you're gonna use for project one. And then one last thing I'll give you guys is GitHub. So the easiest way that I think you can develop code is literally just go to a repository. So I'm going to say test one. And then all these things you can leave untouched. You can create a repository. And then the way I like to do it is create a code space. So this will give you a VS Code on the cloud that's connected with the GitHub repo. And then you can develop code in there. Like, for example, right now, since I just created this just now, so there's nothing in there, right? So obviously I gotta start from as simple as let's say I'm gonna say allow, and then we're gonna say, for example, here's a Python script, so deliverable one.py, something like that. And then what you want is some sort of a magic function. Can I make this bigger? Yeah. Well, you want some sort of magic function such that the input argument, some sort of URL, this is going to be a string. And then you want to return some sort of a dictionary, JSON file. So return some sort of dictionary, we can probably call that result. And then here you want to define the result to be score. Let's set that as none for now. And then explanation. This is going to be a string. So to do, let's set that as a string. And then in here, that's going to be your to-do item, right? So whatever this to-do item is, it's going to take this URL, and then it's going to do something here, and then it's going to return these two things. And then this score is probably going to be coming from here, right? So somewhere here is going to generate a score, and then the score is going to say a number. Like you can think about it as a float, right? So once you have this code developed, let's say now you're done. Like this is, let's say hypothetically you finished, right? Very simple. All you gotta do is commit it, right? So you do a git add, git commit, new script added, and then do a git push. Now you commit your code to the repository. Now you can pretty much just go back and then say test one, and then you should be able to see the code that you just committed. Does that make sense? So this is kind of like an easier way, so that you don't have to do all of this locally. If you want to, it's fine. You're just gonna have to set up the key, which some students told me before that it's kind of like a hassle to set a key. But this way you can pretty much skip that, right? Because this URL is designed in a way that's specifically connected with the GitHub repository in privacy, right? So it kind of, just make it nicer. And then I think you can probably just run this code on the spot. I think Python is installed here, right? Python is installed. And then you can run the code on the spot. You can say Python deliverable one. So once you run it, this is not going to do anything because we haven't invoked it. So you're not going to see anything happen. But if you want to invoke it, you can say something like current result is magic function. And then you can type in some sort of string, HTTP, google.com. And then you can print that out. So this way you can test out the code locally. And then obviously you need to see this happen, right? So I will be doing the same thing. So when you submit the deliverable for project one, all you gotta do is take this repo URL and then go to the submission form. And then submission form will ask you for GitHub URL. You just gotta, all you gotta do is take this and copy paste in there. And once you copy paste in there, I will be literally doing the exact same thing. Right? I'll be literally doing the exact same thing. It'd be nice if you can write this out for me this is what we call a unit test. So it's the line of code that examines the function to see if your function is doing what it's supposed to do. So it'd be nice if you can write that, and then I'll just run your code as it is. And then if it gives a result that it's supposed to give, then obviously, it's going to be a good grade, right? And then if somewhere have mistakes or bugs, then obviously, I'll start taking points off on that. Does that make sense? And then as a good habit, obviously I forgot here, but as a good habit, make sure you have type ins. So these strings dictionary, these are called type ins. And I make sure I have docstring. So docstring looks like this. I think last time I called it comments, but really it's the same thing. So this is just to tell the user what the function is doing. Like this function scores a grade for the URL, and then the input argument is going to be a URL. This is going to be a string. And then the return is going to be results. This is going to be a dictionary, something like that. And of course, we talked about last time, you can have ChatGPT write this. So you don't actually have to write this yourself. I'll leave that to you guys. If you want to write it, of course, go for it. I think you don't have to. I think ChatGPT very well can write that for you guys. Okay, so let me take a pause. Any questions? Yes. So you have to fill in the spot here of what do you think is the reasoning to take a URL as a given and come up with a score. Yeah, so that's a question. I'm gonna dive into different solutions as the class projects, as the class continues. Linear regression certainly can be one. Of course, you can do other things, logistic regression. You can do regular expression. We're gonna talk about that in just a sec. So yeah, you can do a bunch of different things. Yeah. The most dumbed down way, like absolutely zero labor required, is copy this into ChatGPT and say, help me figure out what's a good solution here so that I can have a score. You can even ask ChatGPT to give a couple of prompts, right? You can say, I want the solution here to read the where did it go? I want a solution here to call beautiful soup to read the content, and then I want you to look at the content. If there's names like archive or paper or peer review in this content, then you can kind of mark that higher. Otherwise, mark that lower. So that would be like the most easy dumbed down way to do that without any machine learning. Certainly, the first deliverable you can get away without machine learning. Does that make sense? So machine learning means linear regression, logistic regression. The first deliverable, the first pass of the project one, you can get away without that. Totally fair. Yeah. What's that? Yeah. How do we are kind of using some data. Yeah. 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 So how do we do as a so yeah, exactly. Yeah. Yes. Yeah. Yeah. Yes. Yeah. 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 Exactly. Yeah. You cover exactly. Yeah. Yeah. Cool. Any other question? Good. Okay. It's coming up in an hour, so let's take like a 15-minute break, and then let's come back at 7:13. Okay, let's take a break. Oh yeah, of course. Before I pause my screen, everything is on here. Everything is in here. there's like a whole list of notebooks here. I'll give you the link, but I'm just answering your question. Everything is included. Yeah. Yeah. So I'm sorry. Make sure to share screen. Um, so so again, chapter 3 and chapter 4 are most important one, in the sense that why are they important? They are not hard. They are simple enough that you can still code everything from scratch, line by line, and get away with it, right? Obviously, I have a code to show you guys how that works, and then um, these two chapters also gonna give you the background information of how a neural network works, as in terms of one single neuron. So if you miss out on these two, you're gonna miss out on a whole bunch of stuff in neural networks. So when we get to here, you're gonna feel very confused. So I would say chapter 3 and chapter 4 directly set things up for chapter 10. Which in a usual scenario, in the old days, like if you're taking this class like 5 years ago, usually people will cover up to chapter 9, and then this, they're not going to cover it. In today's day and age, you don't want to do that. And the reason is, once you have chapter 3 and 4, it's already kosher enough to talk about deep learning. And the reason is deep learning is completely based on chapter 3 and chapter 4. So it doesn't quite make sense to just kind of like skip that. And also unsupervised learning, it's intertwined between deep learning and these other stuff here, chapter 5, 6, chapter 7, these are all intertwined together. So that's why the chapters are designed in a way that they're designed. And then, so what we're gonna do, and I'm gonna tell you what I'm supposed to do, and I'll tell you what I want to do. So what you're supposed to do in a class like this is you pretty much hit every topic all the way to chapter 9, and then you hit them hard, right? Hit them hard means theoretical, means math, means exam, stuff like that. I personally don't care about exam because I think it's stupid. So what I'm gonna do is I'm gonna try to hit these to the level that you can apply it. And then I'm gonna try to get here somewhere in the middle of a semester or as early as I can. So that's what I'm hoping to do. So that's, what you're supposed to versus what you're hoping to do. So that's the difference. Personally, just make a general comment. In the real world, you're probably not gonna touch 8 and 9. That's kind of sad because these are actually pretty smart algorithms that people figure out. And the authors that figure out, obviously they're big names in their own domain. But in terms of today's day and age, in terms of industry practice, no one does like decision tree anymore. That's not really it doesn't really do much. Like there's no company that invests money in a data science team that develop decision tree algorithm. It just doesn't do much for the company. You might as well just do this too, or you might as well just do deep learning. So that's unfortunately the case. But it's not for me to judge, right? Industry has its own valuation for chapter 8 and 9. So hopefully, we're gonna talk about that, but we're not gonna spend a whole lot of time there. These other chapters, for example, sampling, model selection, these come and go as a case-by-case base. So it depends on your job. I would say first year, second year data scientists, they're probably not going to do a whole lot of this. You're going to do this when you're in a particular field. Like for example, when I used to work in healthcare industry, they really worry about model selection because they want to know not only compare between different models, but also compare with different features. What can they show the doctors, how the performance are created. So that's when chapter 6 is going to come in handy. Another thing that chapter 6 is going to come in handy is regularization. So if you understand regularization, it gives you a small edge to fine tune your neural network model so that your neural network model is gonna not completely guaranteed to avoid overfitting, but you have like a small advantage in terms of overfitting if chapter 6 is done well. So does that make sense? That's kind of like it's very much intertwined. Everything up to chapter 9, it's intertwined in deep learning. it also doesn't, it shouldn't surprise you when people say that, because people invent deep learning to combine and replace everything else. So that's kind of like the trajectory of how the industry work, right? Again, it's not my rule. It's just how the industry turned out to be that way. So let's get started with linear regression. In terms of linear regression, I think we talked a little bit about that last time. The most easy one is you draw a line. That's the most easy one. I think last time I showed you guys a similar graph, right? What's a linear regression? Linear regression means you plot a plot, and then the feature that you're looking at and the target that you're looking at looks like they fall in line, right? So these red dots are data, so they are data point. The blue line is the model. Makes sense, right? Linear regression is the line, blue line is the model. And these vertical distance, that's the error. So the vertical distance in some domain, it's also called irreducible error. It's an error that's just innately in the data set that if you're going to choose linear regression model, you cannot avoid that. So it's irreducible. And a joke that I told you guys last time, which is sometimes you work on the model and then you show your stakeholder, you say that's the best I can do. And then your stakeholder say, well, what happened to this error? And then you can say, well, that's irreducible. It's because you chose linear regression, right? And then the line is the best you can do, is the only thing you can do because it's linear regression. So these vertical distances, well, you can't avoid that. So that's just one fun thing to notice. Another thing to notice is for linear regression, the error term, right? So these irreducible error, they have to be normal, unfortunately. If they're not normal, you better do something with your model. Does that make sense? So what I mean by that is, if you look at the TV that's less than 50, the error looks smaller. Like smaller means from 5 to 10, right? This is less than 5. This is less than 10, less than 5, right? So the error is smaller. When you get to like 200, 250, 300, the error now becomes this, right? So if you take this distance, you come here, it's like greater than, this is 20 to 25. So if the distance is like this, it's greater than 5. So when you see this happen, it's kind of on you. It's no longer irreducible, it's reducible, right? What I mean by that is there's something here, right? There's some information here that is different from some information here, right? So when you see this graph, you don't know you may not know what the real model is, but you absolutely have to know linear regression is not going to cut it. So that's what this graph means. Why? Because these vertical distance on the right-hand side is much larger than the vertical distance here. Yes. You want to be a little bit careful what you say. It's not the right model. It's an incomplete model. Yeah. So not right model means there's no linear regression. There's no linear relationship here. That's not true. There is a linear relationship. So incomplete means there's something greater than 200 that this line is probably not going to cut it. Like this line is not enough. It's insufficient to explain why this distance is larger and why this is smaller. Exactly. Yeah. Next to the list is information. Exactly. Yeah. We need to information to next order. Exactly. So you're hitting on the right direction. So if I see this, not only will I run a linear regression on TV, you should also create a step function to break the TV down to the ones that's greater than maybe 200 and the ones that's less than 200. And those two variables can be additional variables. Does that make sense? Because of course, this is by eyeballing, right? You can then debate. We can have an argument and say, okay, is it 200 or 150, right? Well, I don't know. If we have disagreement there, then we don't have to argue. We can just run both. Whatever's higher performance on a Hello test set, then it's going to be the final model. But that's the rationale, right? You look at the graph, you're like, oh, somewhere here, something's something's not right. The line is not going to cut it. This distance is wider than this. Maybe there are different models that we can use, right? So that's what that's about. The easiest way I can show you guys is maybe I need to draw this. The easiest way I can show you guys is probably something like this. You Is there a pen I can use? All right, I'll do it here. Annotate, right? Okay. Can you guys see this? Okay. So the easiest way you can do is find a cut, whatever cut you want, and then use that as an indicator function. And then what that basically means is somewhere here, you're gonna create another function like this. So your function can be, so now your new function, let me use a different color. Your new function might look like this. Right, so that additional bias is going to be dependent on the indicator that you created. And then maybe that'll be a better fit for the dots here. And then if you're going to take care of this, then maybe there's a different model. And you just continue to add additional features. Of course, you also don't want to overfit, right? Because the more feature you add, the more likely you're going to overfit. We're going to talk about that in the future classes. But for now, you just need to realize that that's an incomplete model. Yeah, the linear regression will take care of the slope. Yeah. Okay. This is the error rate, not error rate, sorry. This is the loss function called residual sum of square. That's what RSS mean. This is if you want to write it out, like every single observation, meaning that there's an index here 1, and then you see there's an index here as also 1. That means this term is for the first observation, like literally the first dot. And then of course, if you have n dots, then you need to write out all of the error for all of the terms. If you have n sample, then it's 1, 2, 3, 4, all the way to n. And then the definition, this is actually defined, so there isn't really question of why necessary to do that way. You don't have to do that way. That's just one of the loss function that you can choose. And this type of loss function is probably the easiest one. It's called residual sum of square. So a linear regression is essentially set up this loss function, and then the goal is to minimize that. So the notation that we're going to use is minimize min. That means minimize RSS, residual sum of square, and then residual sum of square is defined by this giant thing. This subscript beta 0 and beta 1 means that you can control beta 0 and beta 1, meaning that you feel free to change what is beta 0 and what is beta 1, such that this RSS can be the least, can be the smallest. And it should somewhat make sense because there's a square term here, and a square term here means that your function probably look like this. Does that make sense? So this square term dictates the final shape of this formula is going to be something like that. It's a U shape, which also means there has to be a minimum point here. Exactly, local point. Yeah. So and also because this is something square, that means you have a global minimum or a global optimum. Like you're not gonna get like something weird, like you're not gonna get this. That's not this is not square. Then no, this is square, this is not square. Okay, so with that being said, I'll say a little bit about this. This is a derived results. So in terms of linear regression, fortunately, beta 1 and beta 0, you notice that there's a hat here. Hat here means it's a solution, it's an estimate, right? Fortunately, the beta 1 and beta 0 has a closed form solution. And then obviously you can derive that. I have notes in the in the markdown file that explains how to derive that. I can show you guys real fast. Let me go to the notes. So we go to the course page, and then you scroll down to linear regression. It teaches you how to derive it. You start with the loss function here. Let me make it bigger. So start with the loss function, which happen to also known as sum of square error. Sometimes you hear mean square error. They're really talking about same formula. So how it works is you take partial derivative based on each of the controlled variable. In this case, it's beta 1, beta 0. And then you set it as 0. The reason you set it as 0 is because imagine you have, where's my pen? Imagine you have a curve like this, right? If you take the slope, it's whatever the value is there. It's a slope of that line. And then if you set it as 0, then guess what? You are forcing the slope to be here, right? Because when your loss function is something square, the only place the slope can be 0 has to be this dot, this location. That's the only place it can be 0. So this solution kind of enforce the final result of, in this case, beta 1 to be the best answer. But that's only the case for linear regression. If you go to like neural network, go to other places, you're gonna have the wrong gradient descent. And you may or may not run into the global optimal that fast. This is the unique solution. This is unique to the linear regression setup. Okay, so now let me take you to the slides. This is a visualization. Let me hide this. Sorry about that. This is a visualization of what the loss function might look like if you go from a 2-dimension to a 3-dimension visual. So 2-dimension looks like contours, and 3-dimension kind of looks like this shape. It's still a U shape, but in a sense that it's kind of like it's kind of like a curve, like a hand, sort of like that. And then it kind of gives you an idea that if you randomly initiate a set of beta 1 and beta 0, you're probably going to be here, 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 and then the goal is to move there. So that's what the so that's what behind the scene happens when you want to solve for the best solution for linear regression model. Now here's a couple of caveats that it requires some math to understand it, but obviously I'm not going to test you guys on this. As long as you can work out the project, then this is kind of like on a first name basis. Like I hate that question, right? I get a question all the time. How accurate is the model? I'm just gonna tell you guys right now that question is wrong, right? Here's why it's wrong. If you just Google it, where's my? If you Google it, the accuracy can only be defined when your predictor, sorry, when your target variable is binary. So accuracy means this box and this box sum together divided by all of the boxes. That ratio is accuracy. That's it. And only in that scenario. In a linear regression setup, you're not going to have binary, right? In a linear regression means that the things that you're predicting is like continuous numbers, like sales, stock price, like temperature, right? You're not going to get a binary answer. And if you're not going to get a binary answer, the question, how accurate the model is, probably doesn't mean much, right? Exactly. Exactly, that's exactly true. So, but then, you talk to your boss, they don't know other language, right? You talk to your boss, that's the only language that they do know. So, unfortunately, we kind of have to come up with with some sort of explanation how to interpret that language. So, so a couple of things here. One thing that's interesting is if you look at this error term, it turned out that the variance decreases the more sample that you use. Now, that's actually a very interesting phenomenon in linear regression. So if you work out the math, if you do a PhD in statistics, that's kind of like one of the exam problem. So if you work out the math, it turned out that the variance of this mu hat can be written as a sigma square over n. The sigma is the variance of the estimator in your model, and then the n is sample size. So if you take a look at this ratio, if n increases, meaning that if you have more and more, if you just literally just collect more data, you actually realize that this variance gets smaller, so that you can actually claim without doing anything else, without doing any additional work, you can actually claim that your model is getting better. That actually is a thing that people do. That's incorrect. In practice, people do that, and you get away from doing that. But it's just incorrect. It's a correct statement in terms of how you use your statistical knowledge. It's incorrect in terms of the choice to use that statistical language at that situation in your job. Does that make sense? So there's a difference. So people get away because they thought they're not wrong. They're not wrong on paper. They're wrong by making the choice of using that as a reasoning. So that's one thing. Another thing is there are a bunch of stuff here that you can actually do some weird tricks here. Like for example, another thing that people do, right? Standard error of your coefficient beta 0. Turnout, if you work out all the math, it looks like this thing, right? It looks like this thing. And then if you look at this thing, it turns out that if you collect more samples, this term disappear, and then you're gonna be left with this term. And then the X bar at the moment, it doesn't change. So then this standard error and this term down here actually has a reverse relationship. So there are weird things that people do, and then they make arguments of, okay, how these two things can relate each other. It's completely unnecessary. It's completely unnecessary to go into that rabbit hole. When you scale up your sample size in your data set, you probably want to use a different model than just a vanilla linear regression, because then you have more features, you have more tools to use. You're not just limited to that. So again, you fall into a rabbit hole of saying the right thing in terms of the statistical language that you use, but it's a wrong choice to use that statement at that time. Yeah. So in terms of interpretation, the best thing that I can tell you guys about this is to come up with a simple example. Let's say you have a simple model, y equals to 2 plus 3x, right? It's a line, it's a linear regression. That's what that look like. If you have a beta 0, beta 0 is the first term. If you have a beta 0 that magically, for some whatever reason, you collect data, you train your model, you get 1.99. So 1.99 is very, 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 very close to 2, right? So then you can kind of say, okay, this is probably a good guess, right? This is a good guess, not just because this number is close to this number. The reasoning behind that is, if you take a look at the difference, so 1.99 over this, that difference over standard error is large. Does that make sense? So you want that to be as large as you can. The reason you want that to be as large as you can is because not only do you want to know that this is 1.99, you want to know that if you repeatedly train this model in a different, like let's say you have multiple universe, right? Universe number 1, you get 1.99. Universe number 2, you get 1.98. Universe number 3, you get 2.01, right? So if you repeat the experiment in different universe, then you can calculate the standard error of all those beta zeros from all those universes. You want that standard error to be as little as you can in relationship to how different this is from this number 2, right? So all of that is kind of like a layman's term of hypothesis testing. So if you learn a stats class, they teach you hypothesis testing. It's pretty much what I just said, right? So in terms of interpretation of how accurate the model is, in terms of statistical language, we are talking about how close your estimate is to real number. And on top of that, what is the variation of this number? Alternatively, think about this. Why do you want the variation to be small? Well, you can think about the opposite. If you get 1.99 today in universe number one, and then tomorrow in another universe, you get -10. -10 is far apart from 2, right? Then in that case, you will have a larger variance. And if you have a larger variance, then guess what? You are really not on the target every time you guess this number. And that's going to be a problem. So so unfortunately, that's what people mean by how accurate is this model, right? It's a different language in terms of like we're talking about the relationship between these two numbers, right? We're not talking about this, even though in real world this is the correct definition of accuracy. What is the accuracy of your model? Well, you need to be binary first so that you can calculate true positive, you can calculate true negative, and then you sum this up, and then you divide it by the 4 cells. That's accuracy. Okay. Another thing that people do is the confidence interval. Confidence interval is you take the estimate, and then you move up and down 2 standard deviation, and whatever that range is, that's confidence interval. I don't think in real world people focus a whole lot on this. That's the last thing I saw. The standard error is probably the only thing that you're going to focus on, and that's pretty much it. One example I can give you guys, this is just my personal background. If you work at a hedge fund, you probably heard this Fama-French 3-factor model. Let me see if I have a good picture here. Usually there's a good picture online. Let's see. I can't find it at the moment, but wait, here it is. So a good example of why people look at standard error, and this is a domain specific, right? You don't do that for every single industry. You do that here, right? So this is the famous table. Typically, what people do is whatever trading strategy that you developed, you benchmark against Fama-French 3-factor model. Fama-French 3-factor model is a famous model that they won Nobel Prize. And then basically what it says is a partition stock universe into different quintile, different quartile, things like that. When I was at EQR, I worked on this model for a year, and then essentially the heavy lifting is on how you partition stock universe, and then people do make money by doing that. So it is a testable, it is a very testable, very profitable strategy, and it's still running out there. So for those of you that's interested in finance topics, this is a good way of applying the standard error topic that we just talked about in the slides in the industry. So what you see here, like you have a first table that pretty much lists out the statistics of the alpha and the standard error. Why do they have these 2 rows up front? I mean, I literally just find a random table. Why do they have 2 rows on front? This is a standard practice in terms of how do you explain your model is beating the benchmark, and not only is your model or your strategy is beating the benchmark, it beats the benchmark by a very consistent, like the performance of beating benchmark is very consistent. Well, that's easier said than done. How do you convey that message in an academic paper? You use standard error. So alpha is the intercept in your linear regression. And then the intercept basically means, so you can think about like this. If you have, let's say I draw a line. Let's say that's my regression model. The intercept is this vertical distance, is this distance here. Let me use a different color. So intercept is this vertical distance. So literally the first 2 rows, what they're saying is every every quintile of brackets of stock universe based on their strategy has some sort of an alpha term, and then some of them are positive, some of them are negative. But what they notice is not only are these numbers presented this way, they're also very, 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 very large relative to the standard error. So the first row and the second row are important to be shown together. Does that make sense? And then another thing that you can do from this first two row of table is you can trade off the strategy by buying the 10th bracket and then short sell the bottom bracket and then profit on the arbitrage. So that's what this table means. You don't have to understand the financial terms. What I'm trying to say is this is a direct adaptation of standard error and how standard error is used in real world. Any questions? Okay. The standard error is also used for hypothesizing. I think this I'm gonna probably just skip that because it's probably too deep into the statistical term. And then here's an example of doing that. I want to use the rest of the time. I think I'm gonna stop here in terms of slides. I'm gonna use the rest of the time to show you guys how to do this in Colab. And then we're gonna hopefully to try to do this complete from scratch so that you get a sense of the theoretical stuff, and then you also get a sense of how to do this using Python. Okay, so let me go here. Can you see this? Okay. So this code is written for classification, but for the time being, I'm going to skip the sigmoid function because we're only looking at the linear regression term, right? So in terms of, actually, let me start with TensorFlow first. So in terms of linear regression, in practice, there's like so many packages out there, right? You know, you can pretty much do any package that you want. The easiest one is probably using scikit-learn. But of course, I think scikit-learn is too much on the surface that you don't get to see what's inside. And I think sometimes that can be a problem. The reason I'm showing you guys this is because A, we all understand what linear regression is, and B, you get a little taste of what's inside of a neural network. So that's what's important about this code here. So step number one is you take the weight and then you do a matrix multiplication on your data, right? So X is the data and the W is the weight. And then sometimes we have bias, and that's the letter B. So the standard code is just a matrix multiplication, and the syntax is literally you call the linear algebra package, and then it's called matrix vec. So you throw X in there, throw W in there, it will do the multiplication for you. The benefit of doing this is you don't have to worry about dimension. Like for example, if you put two matrices together, the inner dimension has to match. This way, it does it for you as long as your X and W is well defined. In some packages, if you're coding from scratch, like for example in NumPy, you're gonna have to worry about dimension yourself, which sometimes can be painful. So that's why TensorFlow is a good practice. And then in the end, you add a bias. And that's kind of it. There isn't really anything else to be said. It's like one line of code, you have your linear regression model. So after linear regression model, you're gonna have to build the loss. So what I'm gonna do is I'm gonna ignore this, and then I'm gonna ignore this for the time being because these are classification topics. I'm gonna jump ahead to gradient descent, and I'm gonna talk about how this can be done in a linear regression setting. So in terms of gradient descent, you have your data, you have your target, that's the Y, also known as ground truth, and then you have your weight, your bias, and also a learning rate. So how you carry this out is you have to calculate the forward pass. So in this case, the forward pass is going to be as simple as linear regression model. So here we're just going to be linear regression model. So look something like that. And then once you have a y hat, then you can throw a y hat in there and then calculate the loss. Now, since this is linear regression, obviously you're not going to have this thing is called BCE, is called binary cross entropy. So you're not obviously not going to have that. So in this case, you're going to have mean square error. So you're going to take a square, sorry, you're going to take a difference, take a square, and then you take the average of that. So that's going to be your loss. And then after you have the loss, you then update the gradients. And then this is the code to update gradients in the TensorFlow environment. So let me take a pause. Any questions regarding this? Good. Okay. And then last but not least, this is called making an inference. In terms of linear regression, the difference will be you can comment that out. The difference will be you call linear regression function, and then you throw this in there, and then it creates a y hat. Good. Okay. So that's the logic to do it in TensorFlow. Now, of course, you can also do it in Torch. I think I have code down here doing in Torch. Yeah. So down here you can do it in Torch. The logic is exactly the same. It just Torch has a different syntax. And then just one comment in regards to this. In terms of project, you don't really have to follow. I mean, you can do whatever is comfortable for you. I don't impose strict rules on Torch or TensorFlow or whatever scikit-learn, things like that. You can kind of do whatever you want, as long as it makes sense to you. Another comment I will make is, please don't waste time on figuring out a syntax. Either you know or you don't. If you don't know, just Google it or ask ChatGPT, right? There's zero value in you reading internet for 5 hours, figuring out the symbol of matrix multiplication of Torch is this add symbol, right? There's no logic there whatsoever, right? They just use a symbol as a cute thing there, right? So yeah. So let me take a pause. Any questions? Okay. Yeah. So so you just assuming this point that you start you start here, square that like it's square. Yeah. No way. Yeah. Yeah. So no, that's exactly correct. So a small thing you want to be a little careful is let's say you're doing a gradient descent. So it looks something like this. This is the error, and then maybe this is your parameter. Let's say this is a beta 0 or beta 1, whatever parameter you're trying to optimize, right? If you choose learning rate to be too large, let's say a large learning rate, I'm going to use a different color. Let's say blue is large. This learning rate is large. If it's a large learning rate, what you're going to do is you're going to do something like this. Yeah, exactly. So when you get down here, you're not going to get to this point. You're going to do something like this. And you're never going to get here. Yes. And that's going to be a problem. The other case, right? The other end of spectrum, let me use a different color. The other end of spectrum, let's say green. Green is small. If you use small learning rate, you're just never going to get there. Like you're going to be doing this a million years, and then you're never going to get down there. Yeah. So in industry, what people do is learning rate decay, right? So you start with a large learning rate. So you start from here, and then somewhere down the road, meaning that when you see the loss, it's no longer decreasing. It's kind of like zigzagging somewhere, or plateaus, right? That's when you drop the learning rate. Yeah. So yeah, exactly. Yeah. So Exactly. Yeah. So you won't know that unless you physically run the neural network or physically run the algorithm and you plot out the loss, right? And you see the loss is not going down. Yes. Right? So you won't know that unless you do that. Yeah. You don't want to do that every single time, because you don't know you don't know in the real world you don't know the slope of this. This is kind of like a fake imaginary function that is not real. Yeah, exactly, exactly. Yeah, yeah. And then to answer your question, there's also some time that there are holes here. I don't know if I can do this here. Can I erase this? Oh, erase the whole thing. Let me redraw a new picture. So sometimes there are holes in the middle. Like what I mean by that is like that. There are holes in the middle. So effectively what that means is you're just doing a gradient descent. You're like, I'm doing this, I'm doing this. And then from here you get a jump, right? Um, but then what if you happen to be at this spot here? Then you're like, oh crap, my algorithm just crashed. That does happen once in a while. So the solution there is you change the learning rate. Um, yeah, no, that's a good question. Any other question? Good. Okay. Um, one last thing I want to show you guys before we take a break and come back um, is uh, some something to do with AI. Hang on one second. Let me erase this. Give me just one sec. Let me find it. I think it's probably this one. Let me install it and then let me instantiate this and let me explain a little bit what's going on here so that you guys get like a whole picture of what's going on. But it takes a moment to instantiate this. Okay, now this is loading. Let me just explain a little bit what's going on. So let me start from, where's the code? This is just a package. Let me start from here. So number one is to make an API call. Sorry, number one is set up API key. We talked about that earlier in the hour. And then this section here is a coding agent that writes code for you, right? It's no different from if you just go to ChatGPT and say, write me a function, right? So it's the same setup here. The package I use here is called AutoGen. It's an open source package by Microsoft. So all you gotta do is say Microsoft AutoGen. You get the package here on GitHub, or you can go to their main page. That is here. They'll explain what's going on. Basically, long story short is it's a one good example of what agentic AI means. And I'll explain why this is related to data science and to linear regression in just a minute. But let me talk about this first. So of course, there's papers behind it, there's package behind it. So it's a very real, tangible thing out there, which is why I think this is important. But essentially, what they're doing is this: you can talk to an agent, and the agent can not only answer you in terms of natural language, but it can also inject certain function by either you tell it or it will write a function for you on the spot, and then you can then execute it. So that's kind of like what that means. And then once this is initiated, let me show you guys what this is. I don't know if let me reshare. Let me reshare this. I'm sorry, give me one sec because I need the sound. This is a live demo, so if this craps out, then apologize upfront. I'm hoping this works. Mm. Hello? Let me try again. Hello? Can you tell me a joke?
Sure, here's one for you. Why did the Scarecrow win an award? Because he was outstanding in his field.
I don't understand what is Fibonacci number. Can you explain to me?
The
I think
Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. It starts with 0 and 1 and follows a pattern of 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. This sequence is commonly found in nature, such as in the arrangement of leaves, tree branches, and shell spirals, fascinating mathematicians and scientists for centuries.
Thank you. Exit the program.
You're welcome. If you have any more questions in the future, feel free to ask. Have a great day. Goodbye.
Okay, so this is an example of not just interface, not just natural language interface, but also you have audio behind the scene. And then I can kind of unpack this a little bit. So if you look at the source code, which actually just literally just spit out in here, how it works is you will start a simple recording using Python, and then I will talk to it. It will record and save as a WAV file. So I actually have a comment here that says audio.wave. So that's what that's what that comment means. So it's an indicator for me as a developer that this line of code all the way to up here, the audio is saved and the WAV file is there. And then if you look into the directory, that's the WAV file that's being recorded to the previous response. The WAV file can then be packed together, make an API call to OpenAI. It will actually consume that WAV file. Actually, I'm sorry, I missed a step. So you take the WAV file and you actually have to transcribe it back to the text. And then the text, you can then make an API call to ChatGPT or whatever other model that you like. And then you get a response back. The response back, you then convert it into another WAV file. So that's what this output.mp3 is doing here. It is the converted sound of the text coming out of the response from a large language model. And then you just play out loud. So that's one iteration. And then the whole thing is just you have a while loop to iterate these steps until you hear a keyword or trigger word, such as exit the program. Then exit is kind of like a keyword. You can just stop the for loop or while loop. So that's the logic behind the scene. Source code are all here. You can read through it if you want to. I actually have different environments for you to play around. Like for example, here I think I have different assistant that is designed to take on different persona that you can talk to. Like for example, here's a therapist. Here's actually a McDonald's menu that you can talk to it. I want you to kind of experience it. Again, all the code will be online. You can play around with it. The only thing I'm not going to provide you is API key. So you guys have to use your own API key. But the code is up there. All the code is open source, right? So you can as long as you have API key, you can reproduce this by yourself, right? When you play around with this, the problem is it has issues memorizing the exact number, because the reason is this whole manual is embedded in one big string, and then it's kind of asking too much of ChatGPT to know that, hey, previous time when I mentioned Big Mac, I'm talking about this Big Mac here. And then today, if I'm talking about sandwich, you have to recognize it's Big Mac. But what if sandwich can be a McDouble or whatever, McMuffin or something else? So it gets the number wrong based on semantics. And then if you're talking about something that maybe two items maybe talking about same, like similarly, like semantically similarly, then that's when numbers will get wrong. Or sometimes people will say about dessert. A dessert can be a lot of things on this menu, That's also when the numbers can get wrong. So play around with that and then see how different that can be, right?
Being ambiguous, or is it the input you've given to it?
That's a good question. I'm gonna say a little bit of both. The user prompt certainly is a key component. If a user says something that's not clear, I just want dessert. Well, who knows which dessert you're talking about, right? If you have a different data type, like such as a JSON file, then you're gonna have to work around the strings and key value pairs. Then it depends on how you engineer that data type. I don't know if that's going to be good or bad. It depends on how long the data type, it depends on how you engineer the data type, and then the key in the JSON file, is that key known to the user or no? If the key is not known to the user, the same problem could very well happen. Unless you physically engineer in a JSON file that dessert is a particular key, and under dessert, there's a apple pie or something like that, then that's a different story. But we cannot generalize that, right? That's dependent on your domain expertise when you are creating that JSON file. Yeah, that's a good question.
There's a mission. So we're getting data in a JSON file. So that GPO. So it goes. It is
Yeah.
It's a layer. It only such.
Yeah.
You don't have data
Exactly. Yeah. Yeah. Okay, so that's one task I want to give you. I really want to get to linear regression because that's why we're here today. Let me close this. And then I think there's another one here. This one requires a Mistral AI agent. It should only take a few minutes, and after that we can probably take a break. So let me install this package, and then it requires API key, so I'm gonna start loading that. And then there's a chatbot here. So while this is loading, I'm gonna take you to Mistral AI just to give you guys a look of what the console look like. Just same way with OpenAI, right? OpenAI has API doc, has login, has API key, right? Mistral AI is a competitor of OpenAI, and then you can log in, same thing, right? Just use your own email, and then you can pretty much see a platform like this. You can define your own agent, you can fine tune your own model, you can have your own data sets, whatever, and then API key is here. Right, so you just click on that, get your API key, same story, right? Copy from somewhere, save it locally, or save it using the secrets. Just keep it safe. And then the thing I want to show you guys is this agent. So I went ahead, I already created one. This agent is specifically defined to write code, right? So you can click in there, and then let me zoom in a little bit. It doesn't really, I didn't really write anything fancy. Literally what I write is you're a programmer and then you can write any program for users, language including Java, C, JavaScript, Python, blah, 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 like whatever, something like that. I just literally, this is probably the easiest prompt that you can probably come up with, right? Anyhow, so it's an agent that follows certain prompts. And then once you follow a certain prompt, then obviously you can imagine it writes code for you, right? And then that code can be exploited from the response, right? And then I'll show you guys a demo. But the way you exploit that code is by looking at keywords in the string. So let me give where's my pen? So here's So so let's say you write out a response. It looks like some sort of paragraph, just like that, right? Until a certain point in the prompt, it says dot 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 Python. This is the keyword that you can use to anchor on the solution of the code from the response, so that all these other crap, you can ignore that, right? So the notebook is designed in a way that it does that for you already automatically, right? So it will take the response and use the keyword as anchor, extract the code out, and then it will actually run the code for you. And that's when things get really interesting. And once I show you guys this, you probably don't want to code anymore. So, okay. All right, so that's done. Okay, so as a demo, finally, right, come back to linear regression. As a demo, you can go to the file, and then in the sample data, which is the default folder that every Colab session will give you, every time you open new Colab, it will give you that. And you just go in there, and then you see a bunch of things, right? So today we'll talk about linear regression. Obviously, we're going to use a regression data, which is California housing data. And then this data set, it's going to be a regression problem because you're kind of predicting housing value. But let's just take a step back. Let's say I have no idea what's in the data set, right? Let's start from like step 0, right? So this one, it's a chatbot version, so without the sound and all that stuff, because I don't want to take too long. So you can say something like this. You can get a path, copy path. You can say, I have a CSV in this path. I want you to write Python code to read it for me and print out the row, the number of rows, the number of columns, and the column names. At the moment, it will take the prompt, which is whatever I just typed, as input, and it will make an API called Mistral AI agent. Mistral AI agent will then look at this and then try to write some Python code for me. And then I get a chance of review it before I execute it. So this is the answer that you roll. Certainly below is a Python script, blah, 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 right? And then this is the Python code. So it's going to import Panda. And then it writes a function here, says read CSV and print info. And then docstring, whatever, right? Typings, right? These are standard format to write a Python function. And then the code is here. This is a number of rows and columns. It comes from df.shape, makes sense. And then you want to display the columns, df.columns, also makes sense. And then print things out, right? That's kind of it. It's a very simple function. Once the function is defined, obviously you want to invoke it, right? You want to call it. So I have 2 lines of code here to call the function. Once the code is written, we're not done yet, right? Because I physically want to run the code, but I'm too lazy. I don't want to physically run it. I want to have a chatbot. I want to have an agent to run it. And here it actually says, what name do you want to save the script before I actually save? So I can just say test1. And then it asks me, do you want to execute the code? I say yes. I don't really have to do these 2 lines. I can just run it on the spot. But I implement this, give you guys a taste of, in the industry, you always want to have some sort of safeguard. Does that make sense? You don't want to just have AI generate something and then immediately run it, right? That's not a good practice. So you want to have like 1 to 2 layer of safeguard, just, just make sure nothing happens. So yes, right? Letter Y means yes. It's then going to physically run it. And it ran it, it says executed successfully, number of rows 17,000, number of columns is 9, and these are the columns. Now here's when things get interesting. Here is when human comes in, and this is the part when human is, actually, I might add, never ever be replaced. Anything else can be replaced. This is the part that humans will never be replaced. It is up to me, human, to tell the computer what is the target I want to predict. You can say you want to predict longitude. I would probably argue that's not very interesting prediction. Why do you want to learn longitude? It doesn't mean anything. You can say you want to predict housing median age. Well, why do you want to do that? I mean, you can certainly do it. It's just not an interesting project, right? The interesting project is if you can predict the housing value, right? That's the interesting project. Now, of course, this data set is kind of like a textbook data set. Any person look at this will know that's interesting, right? In real world, it's maybe not that clear, right? And that's when domain knowledge comes into place, right? So obviously, last thing I want to show you guys is a linear regression model. So I can say, great, now add a new function that does a linear regression model for me. And typically people will just stop there, right? I will probably challenge you guys to pick a particular package and kind of trying to ask chatbot to do a little bit more to that package, right? For example, using stats model package, I want you to print out the, oh, before I do that, I forgot what I just said, right? I need to tell computer what is the target variable, right? So set the target variable to be this guy, right? Literally just copy here. Set target variable to be median housing value. And hopefully I didn't miss out, okay. And use the rest of the columns to be features. Print out statistical results for me. That's it, right? That's too much instruction already. So hopefully it got it, and hopefully it will write a computer, hopefully it will write a new function for me that does all of that, right? So not only does it read the data and print out the columns, it also basically just do the linear regression for me. Wouldn't that be nice, right? So again, it's gonna make an API call to Mistral AI agent. Same thing, you can use whatever agent you want, you can use whatever large language model you want. How accurate, I have no idea, but the demo here is to use Mistral AI agent. First function doesn't change much, right? Because I said to add a new function, right? The new function being added here is called perform linear regression. Same style, great. So that's pretty clear for me. Read the data, define the features, and I set the median housing value to be target, right? It did do that, right? That's there. And then features is everything else. So whatever's not target, that you drop the target, then everything else in the columns, that's going to be your feature, right? So that's your X, that's your Y, and then maybe you add a constant. I did not say anything about that, but the default linear regression version is that it has a constant, it has the intercept, so fine. And then after that, you just run your OLS, right? So in a stats model, you see here it says SM, that just means short for stats model. I think it imported from the top, yeah, here. It imported from top, and then it feed the model, and then print out the model summary. That's a function. Now I want to invoke him. So same thing. Let me hide this out because I can't see them. Do you want to save? Yes. I'm going to give a new name, test2. And then I say yes, capital Y. And then it will run the function for me. Boom, there you go. That's the results. Right. So we don't need data scientists anymore, right? You just talk to a chatbot. So that's pretty much it. Additional thing I want to show you guys is if you refresh the directory, these two scripts should be saved here. The thing should be very easy from here is you download this, upload to your GitHub, and then end of session, you just submit that. So it indicates to me that you're in class today. All right, let's take a break and then let's come back in 10 minutes. And then we're probably just going to jump right into Q&A because that's pretty much what I want to cover today. Right, let's take a break.